Hey guys, welcome back. I was talking about microgrids before, and this video is a sequel to my previous video. So in this one, I'm going to talk a little bit about our research and what the different areas of research are for microgrids. So it's a growing area. It started around 2010, and it developed gradually, and in the past years, especially in 2014 to 2018, there's been a lot of papers being published in good journals such as the IEEE transactions on smart grids and IEEE transactions on power electronics. So these are pretty highly ranked journals, impact factor around 8 something, around 7 something. So, and then different journals by elsewhere, such as the Journal of Electric Power System and Research. So I myself have some papers in this, and then International Journal of Power Systems, so impact factor around 4.8 something. So lots and lots of papers have been published in these journals in the past years. Also pretty good journals by MDPI, such as the Energies and Electronics. Again, impact factor is around 3 and 2.7 something, and IET and Wiley. So these are publishing houses, and they have many good journals that are publishing papers related to this research area and others, but we're talking about microgrids right now. So to talk about what are the major areas of research in a microgrid, let's start with drawing a basic structure. So this is my favorite diagram. I always draw it in my class. So we have, let's say we have a bus. So we call this bus 1. It can also be called a node. And then we have a 3-phase transmission, distribution transmission line, right? So this is the resistance, and this is the inductance of it, and together it becomes the impedance. So this is linked with another bus. So this is a basic transmission feeder, a distribution feeder, sorry. And this is another impedance. And then we have another, and so on. So here it's linked with the other power system via a transformer or something. So this is a switch. So what we can do here is that every node has a LC filter or LCL filter. We're going to talk about that a little bit later. LC. And then we have power electronics. So mostly this is a DC to AC inverter. And behind that, there is a series of stuff of control. So there is a PWM generator that is fed by current and voltage control loops. So current control, voltage control, and then we have behind that power control, so P and Q, power control, and then we have restorative loops for frequency and voltage. And then above this, these loops talk to this and this control, and then feeding this and this, we have higher level of control that makes dispatch decisions about active and reactive power, etc. So you can see that this is kind of a hierarchical control system. So what that means is that the time frame of these two loops is going to be pretty short, and this one is going to be longer than this, and this is going to be even longer than these two, and then this is going to be the longest loop. So this is going to be around nanoseconds. This is going to be around seconds, you can say, this one. This one, which may be in minutes, and this one may be in hours. So every 50 minutes or 1 hour, this control is going to update. So one research area that I'm going to highlight for you now is the control of this DC to AC converter and the design of these power filters. So this is one research area that is purely power electronics. So you get to design different stuff like, let's write down here. So one is the power electronics of it. So here you get to design new strategies for switching and loss reduction, etc., etc. New topologies for power converters, new control schemes that are primarily aimed at reducing switching losses so that we have less heating of the switches. And then there is a whole new area opening up about silicon carbide devices and other materials. Okay. So there might also be, related to this, there might also be DC to DC converters that might be drawing energy from DC or AC resources. So this is also included in the same control area. Then we have something related to the control of these loops. So current, voltage, PWM. So this and this are going to be slightly overlapping together, right? So this might overlap. So here we have the design of hierarchical control strategies. So the design of hierarchical control strategies to improve performance, right? Improve performance. So what is the performance in this? So quick response to higher control levels and more stability, and this can be verified through pole zero plots and gain margin, phase margin, etc., etc. Different kind of things, different kind of methods. And then fault right through resilience, etc. Sorry, my writing is not so good, but I'm trying to talk and write quickly. And then we have this control layer that associates with the type of source that you have. And here we have higher level control. So this level of control typically sees the microgrid as a aggregation of energy power sources, and how that power source structure can be optimized in relation to the output it's going to give and the input it's going to take, and the storage, source, etc. And then we can optimize the behavior of more than one microgrids, the interaction they have together and the interaction they have with the greater power system. So we have bi-level control that has one controller here, so a distributed network operator, and then it has some local controls here. So at this stage, we're not worried about the power electronics or the other loops. We're just talking about this thing. So this kind of problems typically involve novel formulation and constraint optimization equations, and like new methods to solve them. And the typical results involve cost reduction, overall cost reduction, and stuff like that. So this is the kind of thing that we have these days in microgrids. So there are typically 3 areas: 1, 2, 3, and then we might have combined sub areas, but I've outlined the big things for you. And then the 4th is the protection systems for microgrids, because when you're talking about a situation where the power is going to typically flow from this end to this end, the relays and protection relays and everything that is involved will have to be updated. So we have to update the protection systems for distributed distribution networks, and there's a whole lot of other stuff affiliated with it. So my own PhD was a more combination of this with a little bit of this, but I wanted to pursue this part in the future, so that's what I'm doing these days with my students now. And then later at some point we might move into control of the how to say, the protection equipment and so forth. But primarily I'm interested these days on the integration of battery energy storage systems with PV systems, etc., in the microgrid. So we have people who are doing projects on multi-microgrid clusters that have battery energy storage systems and electric vehicles. And then we also have people who are working on these control loops. Most people are working on these control loops. Some are working on these control loops, and we're gradually moving forward. So hope to have good results in the future. So please keep following my channel, subscribe to my channel, and press the bell icon so you can get timely updates. So stay happy and stay hopeful, and you can always hit me up in the comments section as well as on my email, which is huramhashimi@uit.edu.pk, or text me on my LinkedIn. So that's Dr. Khurram Hashimi, who's working at UET these days. All right, all of you folks have a good evening. Enjoy your life. Stay in touch. Bye-bye.